Hello and welcome once again, everybody, to the Scientific Origins channel. Today we're refuting some more evolution denial tropes in the continuing quest to refute everything evolution deniers say. It's all wrong, all of it. Here, let me tell you how. So, we're refuting two very common tropes today, and these are very common ones. They're very easy to refute. They've been refuted many times, and I probably could refute them in just a couple of minutes, but I wanted to go into a little bit more depth. So let's see if we can't make this take a half hour instead of just 7 minutes. So those tropes we're refuting today are: the second law of thermodynamics makes evolution impossible, and the ever classic, if we evolved from monkeys, why are there still monkeys? Let's get into it. All right, the second law of thermodynamics. The second law of thermodynamics states that entropy must not decrease, but it only applies to isolated closed systems. And Earth is an open system. It's got a really strong energy input called the sun. You may have heard of it. The sun is continuously putting free energy into the system, on the order of about 1.7 times 10 to the 17th watts. That's billions of watts of energy. And that energy allows for a local decrease in entropy as long as the combined total entropy in the system still increases. So, uh, what this is the reality. These are the facts of the second law of thermodynamics and how thermal systems work. Here's how it refutes what evolution deniers say about the second law of thermodynamics. Evolution deniers completely botch the second law of thermodynamics. They don't understand it. They have a very bastardized version of it that they use. The young earth creationist second law of thermodynamics says everything's decaying. Everything's going from a state of order to disorder, which order and disorder are crude metaphors. We don't really use them for explaining the second law and explaining entropy anymore. Entropy measures energy dispersal, not order or disorder, and especially not the kind of order and disorder evolution deniers are talking about when they use those terms. In physics, it just refers to the dispersal of entropy. The way they're using it, they're talking about, oh, things decay, they rust, they fall apart. So how could you get evolution? Because things have to be getting worse, not better, and evolution says they get better. That's not actually what's happening in the second law of thermodynamics. It's not talking about order or disorder. It's talking about the flow of energy. So what the second law of thermodynamics means, to put it really basically in layman's speech and kind of simplify it a little bit, the second law of thermodynamics means that if you've got a bunch of energy in a bunch of heat in one spot, and it's like high heat in one area, and it's surrounded by areas of low heat, that heat will spread out. The high heat area, some of its heat will spread out to the areas of low heat. That's all the second law means. It means that the heat and energy is going to get more dispersed, and it's going to get more mixed up. And ironically, you actually need that for evolution. It's not a hurdle for evolution, it's the necessary substrate of evolution. And we're about to get into that in this next slide. So, like I said, the second law of thermodynamics is not a hurdle for evolution, it's necessary for evolution. And that's why Answers in Genesis, Creation Ministries, and a couple of the creationist propaganda mills have told evolution deniers, stop using this argument. It's a bad argument. We done goofed. Don't use second law arguments anymore, because the second law not only doesn't prohibit evolution, the second law supports evolution. And here we have examples of multiple papers that show that. So we've got the Statistical Physics of Self-Replication in the Journal of Chemical Physics, 2013, by Jeremy England. He showed that putting energy into a system can cause matter to organize, even sometimes into self-replicating assemblies, in order to absorb and dissipate heat more efficiently. So this is talking about how thermal energy can create a self-organizing system. It can be the fuel for a self-organizing system. And multiple papers have converged on that understanding. So, second paper there, Thermodynamic Origin of Life, 2011. Subsequent updates all the way through 2021 by Carol McCallion. The second law is what drives molecules to continuously combine, mix, and there's selection that selects for configurations that absorb light and emit heat. A system that doesn't do that isn't going to last long. Systems that do will last. So that is the selective force, not unlike natural selection. And abiogenesis, the forming of self-replicating macromolecules, or a chemoton, if you will, is the most efficient system for absorbing light, emitting heat, and organizing entropy flow. And then these are just three specific papers. There's hundreds of papers about this, and it's talking about how abiogenetic systems are the most efficient thermodynamic engine available to dissipate energy gradients, and they do this because of they use that energy for synthesis of organic compounds. So life is a system through which entropy flows. So the second law of thermodynamics does not only not cause any problems for evolution, it's necessary for evolution, because the second law of thermodynamics says, first of all, that you're going to go from a state of high heat to a state of more spread out heat, high concentrated heat to lower spread out heat, and you need that to get particles. You need that to get substance. It also says that things will get mixed up as long as they aren't enclosed, isolated systems, and you need that to get those substances in the arrangement from which a living system can emerge. So not only does the second law of thermodynamics not present any problems for evolution, it's necessary for evolution. So there's that one in under 7 minutes. Good for me. Let's move on to if humans evolved from monkeys, why are there still monkeys? So, first of all, what are humans, apes, and monkeys? So, humans are hominins. That means they belong in the tribe Hominini. And there's a split. The panins is just the bonobos and chimps. There's an argument I think you could make where humans belong in the panins, but we won't get into that right now. Technically, there's a split, and hominini refers to all the organisms on the human side of that split. So you got the split. Over here is the panins, the chimps and bonobos, and over here you've got the entire genus Homo. Homo sapiens, Homo neanderthalensis, Homo denisovans, Homo floresiensis, Homo ergaster, Homo erectus, all of those. So all of those species, chimps, bonobos, and the genus Homo, they all belong in the family Hominidae, and that's the great apes. Apes rest within a more specific group in the Euarchont group. And the Euarchont group includes primates, which are sometimes referred to as monkeys, sometimes referred to as apes, and other things like lemurs and tree shrews, non-primates. Apes rest within the haplorhine, dry-nosed, simiform, simian, catarrhine, old world order of monkeys. So apes are monkeys, humans are apes, humans are monkeys. It's this is something that people confuse a lot. They say, humans didn't come from monkeys, they came from apes. Apes came from monkeys. So humans indirectly came from monkeys. They came from apes, which come from monkeys. So to answer the question, why are there still apes/monkeys? For the same reason your birth didn't erase your cousin from existence. Okay, you share a common ancestor. You didn't come. The reason this argument is being made is because the evolution denier thinks chimps evolved into chimps evolved into humans, and so when chimps evolved into humans, chimps shouldn't be around anymore. That's not what evolution states. Evolution says humans and chimps came from a common ancestor. So it's kind of like how jazz, blues, and rock and roll all come from ragtime. And the existence of jazz, blues, and rock and roll didn't make ragtime go away. These are just descendants of the ancestor. And rock existing didn't make blues stop existing, and rock and roll and jazz existing didn't make blues not exist. They all just adapted through different lineages, and the same is true for the biological groups we're talking about. So, an ancient common ancestor population had more than one descendant. One of those descendants is the what became the entire Homo genus. Other lines of ancestors are those that became modern apes and monkeys. Modern apes and monkeys didn't evolve into us. We all share a common ancestor. So there's a follow-up question that might be asked. Why aren't apes/monkeys still evolving into humans? Well, for one, they fit their niche very well. So there's no selective pressure for them to try and adapt into a new niche. That's the first reason. Two, even if there was a selection pressure pushing them towards a more human-like niche, guess what? That niche is already occupied by the most dominant species on the planet, us. So it would be a really bad idea for an organism to try and compete for that niche with us. We'll destroy them. So selection pressures are pushing organisms away from evolving into that niche, not into evolving into direct competition with the most dominant species on the planet. And I think some visuals might help make this clear if you're still confused on this. Here we have a chart of human and primate species. And if you see that red circle, all of the lines to the right of that red circle are something that qualifies as a human species. Those are all the human species we know of. Very close to that red circle, just like 2 layers up, is the common ancestor we share with chimps and a couple of other species. So as you can see, humans didn't evolve from chimps, pan-troglodytes. They evolved from a common ancestor. All humans have a common ancestor, and that human common ancestor shares a common ancestor with the chimp common ancestor, and that is what that blue circle circles. And then this picture to help it will be even more clear for you. Down at the bottom of the chart, you have the common ancestor of all these groups. You have a line branching off one way into the Sumatran and Bornean orangutans. The other branch goes to the right, keeps going to the right, and then there's a second left branch, and that goes to the gorilla groups. Then there's a third left branch, and that goes to the chimpanzees, and then the final branch that goes all the way right leads to us. And these all draw back to a common ancestor. The human didn't evolve from the orangutan; they all evolved from the node that these lines draw back to. And since we've got the time, let's go ahead and give you some bonus. We're going to really just go hard on debunking a bunch of stuff here and giving you hopefully some taxonomy skills. So this is 71 steps of the human lineage. I don't know if this is every single step, every single clade we belong to, but it's a very comprehensive list. And so every human is all of these things, and that includes other species of humans like Homo neanderthalensis, Homo denisovans, Homo ergaster. All of them will be biotic, metazoan, bilaterian, osteichthyan, pentadactyl, eutherapsid. All of these things describe every human species. And this list is what we are. This is what it means to be a human. This list covers molecules to man evolution, 70 or so steps. So, creationists, when you show up to the argument not knowing any of these steps, you've already lost. This is macroevolution. If changing from biotic archaeans, which are simple unicellular organisms without true nuclei, without a bound nucleus, and without complex organelles, if that evolving into a primate haplorine simiiform catarrhine hominoid hominid isn't a change in kind, then whatever you're defining change in kind as isn't necessary for evolution. And if humans didn't evolve from monkeys and apes and, holozoans, why are we still monkeys and apes and holozoans? Why are we still osteichthyans if we didn't evolve from fish? Why are we still sarcopterygians if we didn't evolve from blowfin fish? Why are we still ripidiscians if we didn't evolve from lungfish? And so on and so forth. Everything on this list is something we still are, And it's because you don't evolve outside of your ancestry. You evolve into a more specific group within your ancestry. And so humans are in a very specific group that's about 71 steps to the interior of the most broad taxonomy, the biotic taxon, living things, period. And continuing the bonus debunking, so to help you understand this better, the all the stages from the previous slide can be grouped into about 6 categories, and we've got the categories here. Group 1, the deep time foundations to multicellularity, and these are steps that developed multicellular organisms. It goes from Archaean to eukaryotic. That was a big transition. Archaeans endosymbiosynthesized alpha proteobacteria and other microorganisms, and instead of dissolving them and using them for food energy, they formed a symbiotic relationship. They learned to cooperate, and eventually you go from archaea to eukarya due to that. Eukaryote is an archaean that has been modified extensively by endosymbiosis. And so you go through these steps. Unicont is an important step. That's the single rear-facing flagellum. That's the first cell we're made out of, and your spermatozoa, and a lot of our other cells are still that. Obozoans, opisthecons, holozoans. This is the line that basically develops multicellularity. By the time you get to apoicozoans and metazoans, you've got multicellular animals, basically. And then group 2 is the body plan architecture. A lot of what decided how our body was going to be happened during this stage of evolution. And it's important to note that these 2 groups, those took like 1.7 billion years just by themselves. The vast majority of the evolution listed in these groups occurred over like 3.7 billion years, and then the last group 6, happened in just a few 100 million years. So these are very long arcs of evolution that developed our body plan. And so the second group is where we developed tissues, a digestive tract, a distinct front and back, our excretory organs like our kidneys, and the backwards facing blastopore, aka the anus. This is where we developed our notochord, our skull, and our olfactory system, and vertebrae, and eventually jaws. We became the bitey boys at that stage. And then group 3 is where that body plan goes from being the body plan of an aquatic organism with lungs to a semi-aquatic organism with lungs and gills, to a fully land organism with lungs and no gills anymore. And so this is the tetrapod transition. It starts with eunathostomatans with true teeth with enamel, and then it goes to osteichthyans, which are bony fish, and then it goes to sarcopterygians, which are the lobe fin fishes, rhipidisties, the lung fishes, and they're just gradually getting more and more land bearing until you get to the tetrapods and the pentadactyl and the reptilians. Then group 4 there, that's the shift from non-mammals to mammals. You start with synapsids, going all the way to mammals. I'm going to do a whole video about that specific transition. It's a fascinating transition in the jaw. I talked about it in a previous video, but we're going to dedicate a video specifically to that. And then group 5 is the mammals developing, since the previous stage ended with the last step before mammals. The next stage is the first mammals, and then all the different mammal groups, one of which is the primates, the group we're in, which is that final group there. And so this fully answers All of the questions evolution deniers will have about humans, about what they are, about why they share common ancestry with apes, about why monkeys and apes didn't disappear with the development of humans. And it also gives you a really deep insight to our taxonomy and our evolutionary past. So, with that, I'm going to consider those 2 points, those 2 common evolution denier tropes, more than done and dusted. If you want more information, there's tons of debunks on this specific topic. I'm sure Aaron Ra, Gutsick Gibbon, Creation Myths, Grayson, Professor Dave, they'll all have videos about this that'll go into more detail, and you can get more specific refutations. You can get a wider array of refutations. I put a lot of refutations in this video for you. So hopefully you are more than capable of dealing with these super common evolution denier talking points now. So that's it for this one. Thank you so much for watching. Be sure to like, subscribe, comment, kidnap people and force them to watch my channel until they understand evolution and biology and they can't stop talking about it. Don't actually do that. I shouldn't recommend you do crimes, but do tell people about my channel, and especially if there's somebody you think is science friendly or somebody you think is in danger of being taken advantage of by science hostiles. Hopefully I can help them and give them a better epistemology. So thanks for stopping by, and we'll look forward to the next one.